Hi people, so we'd be talking about mixtures. And this table right here? It's more than enough a tool to tackle any question that you might encounter. So let's first clear up basics. So what exactly a mixture is? It can be any number of quantities mixed together uniformly, and that will make a homogeneous mixture. So let's just take the example of let's say two quantities, and for the sake of it, let's just take milk and water. So let's say that milk and water, these are mixed in the ratio 3 is to 5. And the total quantity is 80 liters. That means like we have a container, that measures 80 liters, and the ratio of milk and water is provided to be 3 is to 5. So, we can see from this ratio, since the numbers are, I took these numbers deliberately, so you can just easily, see that milk would be 30 liters and water would be 50 liters. So, the 30 liters, the 50 liters water, these are termed as the quantity. Milk and water, these are ingredients, and the quantity of milk, it's 30 liters, the quantity of water, it's 50 liters, and the total volume, that is 80 liters. And now talking about concentration, so the concentration for milk, that would be the quantity of milk divided by the total volume. The quantity of milk divided by the total volume. So in this case, the concentration would be 30 divided by 80. And in the same way, if we have to find out the concentration of water, that would be concentration of water, that would be 50 divided by 80. And as you can see here, if we just have two ingredients, let's say milk and water, so their addition of their individual concentrations, that would sum up to 1. So if we have two ingredients, so concentration of ingredient number 1 plus concentration of ingredient number 2, that will add up to 1. You can even check right here, see, 30 by 80, that's 3 by 8 plus 5 by 8, that is equal to 1, right? So, we are now, done with the basics, that what exactly, we mean by concentration and what we mean by quantity. There's one more thing that you can analyze, that from this ratio, that we had the ratio as 3 is to 5, even from there we could, find out the concentrations. So we could just say that milk is 3x times and water is 5x times. Like, because we know the ratio but we don't know the exact quantities, we can say that the quantity of milk is 3x and the quantity of water is 5x, right? And from there we can say that the total volume is 3x plus 5x, and that adds up to 8x. So again, from these three values now that we know, we can find the concentration. For example, concentration of milk would be 3x divided by 8x, that is 3 by 8. And since you know that there are only two quantities, just by this, just by this value, you can say that the concentration of water would be 1 minus 3 by 8, and that is 5 by 8. Okay, so now we are done with the basics, and let's get to, understanding this table. All right, so in majority of the questions, you will encounter one of these events or a combination of these. So, the first event, that is X% solution is withdrawn. So in that case, it's like if you have 100 liters with you and then 10% of the solution is withdrawn. So maybe you have a bucket, and with the help of a mug, you take out 10% of it. So you take out 10 liters from it. So what you're left with is now 90 liters. And so what happens to the quantity of ingredients, and what happens to the concentration of ingredients? So let's look into it. So for example, the total amount is 100 liters, and we have 40 liters milk and 60 liters water. So if I remove that 10% and I'm left with 90 liters. So for milk, the same would happen, because in the start I told you it's a homogeneous mixing. So this 10% removal, it would happen for the total solution, it will happen for the milk, and it will happen for water. So from 40 liters minus 4 liters, and here minus 6 liters, because 10% of 40 is 4 and 10% of 60 is 6. So now we are left with 36 liters, and here we are left with 54 liters. So now you know exactly what's happening. And if you see this, the quantity of ingredients. So when X% solution, is withdrawn, the initial quantity is multiplied by a factor. And that is actually, if you have, seen the profit and loss video. So in that I explained, if you have a minus 10%. So if you have, for example, minus 10%, so in that case, how your final quantity would be? So you will have 1 plus minus 10 upon 100. So this is your m right here. In that, it's actually a concept of ratios and percentages. So in that video I took it to the context of profit percentages. And in this video we can understand, if we can just look into it, that if we have minus 10%, so the multiplying factor would be 1 minus 90 by 100. That is 9 by 10, right? So if we multiply this, so if with 100 we do a multiplication of 9 by 10, that m, that multiplier, so we would reach that exact quantity of 90. So from 100 we reach 90, because there was a removal of 10%. And you can understand how you can think about it mathematically, that this minus 10% corresponds to a multiplier of 9 by 10, and this is how you do it. So that's what's written here, that initial quantity, this initial quantity is multiplied by 1 minus x by 100, and you get your new quantity, your final quantity after this particular event. And if we talk about the concentrations now, see here I will write initial concentrations, and here now I will write the final concentrations. So you can see for milk, let's say milk is here and water is here. So for milk we can see that the initial concentration was, and now we know how to calculate concentrations. So it is 40 by 100, and for water it was 60 by 100, and the final ones are 36 by 90 and 54 by 90. And this again is 4 by 10, 2 by 5, and this is 6 by 10, 3 by 5. This again is also 4 by 10, 2 by 5. This again is 6 by 10, 2 by 5, 3 by 5. So from this we can understand why this is written here. that actually there will be no change in the concentration of the ingredients. And I just showed you that mathematically. And since it's a homogeneous, mixture, it should have been, it's something that should have been already known, that the concentration will not change, because no matter how much we take out of it, every molecule of that mixture would have the same ratio. So the concentration will not change if you just take out a particular amount from the total mixture, right? And the second event, the story becomes a little more, a little different there. That when you add a pure amount, like for example, you had those two quantities, right? Quantity 1 and quantity 2, or you had your milk and you had your water. So now if you're just adding, you're just adding water, so what happens then? So let's see that. All right. So the second event is when we, add pure water. And it's evident that, when we'll be adding pure water, so the quantity of water would increase and the quantity of other things would remain the same. So, like if we have 60 liters of water and 40 liters of, let's say, milk, so when we add 10 liters of water, so the net quantity of water would become 70, the quantity of milk would remain 40, and the total volume would be 110. So that's something that we can, easily see. And now, if we talk about concentration of ingredients, the concentration of water would increase and the concentration of other, quantities would decrease. And how it would decrease, it's written there. So, the initial concentration of, others, it will get multiplied by a factor that's equal to volume that's initial divided by volume that's, the new volume now. And let's see why that happens. So we have, established that the quantity of others would remain same, right? Quantity would remain same. So when that happens, and again, okay, what was concentration? So concentration was quantity divided by the volume, right? So, and we can rearrange it and say that quantity is equal to concentration multiplied by volume. So in that case, when you add some amount of pure water, let's talk about the initial the initial quantity of water and the final quantity of water in these terms. So initial quantity would be initial concentration multiplied by initial volume, right? And same would be for the for the final quantity. And we know for a fact that these two are equal, right? So and we know that these two will differ. Like for example, if I say that we added 10 liters of water, initially we had 50 liters of water, 40 liters of milk. So initially the volume of the total volume was 100 and now it's 110. So if we just equate this, so we can have that the final concentration would be equal to initial concentration multiplied by V initial V final. And see, here we can, even, see that this fraction would be less than 1, right? So initial volume was 100 and the final volume is 100. So you can see that the, final concentration would be, lesser than the initial concentration, because this is less than 1. And that will happen for the, other quantities. If, we increase the amount, the quantity of water, then the concentration of milk would decrease and the concentration of water would increase. So here we'll have a decreased amount of final concentration, and for water the concentration would increase. And like if in case we have two quantities, finding the concentration of one is enough to find the the concentration of the second one, because concentration of water plus concentration of milk would be, the sum would be 1. So now let's see one example, one question now. Okay, people. So now, we have this question with us, and I have jotted down the main points. So, the question is like that in total we have 100 liters, and milk and water, they are mixed in the ratio 7 is to 5. And then, these activities are performed. So, the order of the activities are like this. So, firstly, 10 liters of, this solution is removed, and then 30 liters of pure water is added, and then 20 liters of that solution is removed, and then 50 liters of water is added, and then 30 liters of that solution is removed. From that solution 30 liters is removed, and then 5 liters of water is added. So now we have to find what's the final state, like what is the final condition for what's the ratio for milk and water, and what's the total volume and the concentration. So it's like you have to find everything, because anything could be asked, right? So let's start. And in such a question, for mixtures particularly, you should keep a track on either milk and or either water. And since we can see that water is being added, so we should keep a track on milk, and I will explain why I'm saying that. So let's start. And we can go two ways: quantity or concentration. So we have lots of option here. The first division was whether to keep track on milk or keep track on water. And then the next choice is that, do you want to keep track on the quantities, or do you want to keep track on the concentrations? So for the first dilemma, because I know that because pure water is being added, so keeping a track on milk would be better, would be easier. And out of quantity and concentration, that's a personal choice, but I like this way better. But first, let's start with the quantity way, keeping a track on the quantity. So let's start. Okay, so the very first thing is to keep a track on the quantity and keep a track on milk. So milk, the initial volume of milk is 7 upon 7 plus 5, because the ratio was 7 is to 5, and this multiplied by the total volume, that's 100. So one thing is that you have to keep after every event, after every activity, do keep in track the amount, the volume, the total volume. So right now it's 100, right? And we have our quantity of milk as whatever this amount would be, 7 divided by 12 into 100. Now the first activity happens, so we now remove 10 liters. So now we are left with 90 liters, right? So after this first step, after event 1, we would be having, we would have been we would have removed some amount. We would have removed 10 liters from 100 liters, and the final volume would be 90. And since we know that in such a scenario the quantity will decrease, and we had the initial amount as 100 and the final amount as 90, so now we can have a multiplier, as 90 by 100. You can think of it in percentage ways as well, or you can just simply see that initially we had 100 liters and now we have 90 liters. So this will be, our multiplier 90 by 100, because 10 liters is removed. 10 liters, from that 100 liters. So 10% was removed, and that will be 90 by 100. And you can also see it in this way, that you have these two quantities with you, 90 and 100, and your multiplier would be less than 1. So would it be 90 by 100 or 100 by 90? So it will be 90 by 100. These tricks help you to quickly calculate. So after event 1, we have our final answer as this, whatever this will be, calculated, the final output. So let's move to second event. So after the second event, which is, adding of 30 liters of water. So now, from 100 liters, your total volume became 90 liters because you removed 10 liters. And from there, you have now 120 liters because of the addition of 30 liters. So now you have 90 by 100 into 7 by 12 into 100. And just think, did the quantity change of the other quantity change? Does that happen? And that will not happen. So in this case, in second case, it will remain unchanged, because the quantity of milk will remain unchanged when the quantity of water is increased, when pure water is added. And that's the reason I told you to, are when you are adding pure water, track milk. That's the reason, because few of your calculations will be decrease, the amount of work you'll have to do will decrease. You can try on your own to do it by tracking water, but that will be more calculative, because 2 after 4 after 6 steps are removed, and the only thing you need to do is just keep a track on that volume, because you're adding 30 liters, so your volume changed from 90 to 120. So now let's talk about what happens after activity 3. So now your volume, because you remove 20 liters, now your volume is 100 liters. And you know that there would be a multiplier that's less than 1, and that will be 100 by 120 into 90 by 100 into 7 by 12 into 100, right? So this multiplier is because of removing those 20 liters. And then after 4, because we are adding pure water, we just there will be no change in the quantity of milk. We just need to keep a tab on the amount, that's the total volume. So we had 100 now, so from that 100, 50 liters of water is added, so now we have 150 liters as the total amount, the total volume. And after the fifth activity, so you are removing 30 liters now. So now you will have 120 liters as the total volume. So now you have two, your initial volume was 150 and your final volume now is 120. So now you'll, multiply a multiplier, that is 120 divided by 150. So you have 120 divided by 150, and that will be multiplied to our previous, whatever that calculates to. We have 5 by 6 multiplied by 9 by 10 multiplied by 7 by 12, and then that's multiplied by 100. So this was after the fifth event. And after the final, the final thing that happens, the last event, event number 6, you're adding 5 more liters. So this 120 will become 125. So this 125 is the final volume, and you also know the quantity, milk, the quantity of milk. So these two, you have these two values with you, and now these are enough to answer any question, and let me tell you how. So after analyzing all the events, this is what we finally reach, that the total volume now is 125 liters, and this is the quantity of milk. So let's just calculate the value. So this will be 4 and this will be 3. So we would have the quantity of milk as 35 liters. So now we have found that the quantity of milk is 35 liters. The total volume is 25 liters. So the quantity of water, it's obvious that it will be 90 liters. And from here we can find the concentration as well. This will be 35 by 125. So which is 7 into 5 and 25 into 5. So this is 7 by 25. So the concentration of water would be 18 by 25. And see, I just founded this, and from this value I just cm was 7 by 25, and you just have to subtract it from 1 and you reach sea water, because we only have two quantities here. So this whole was the process for finding out using by keeping a track on quantity. And because we had added pure water, we kept a track on milk. And so eventually we found it out everything. And now let's talk about how to reach the same answers using concentration, by keeping a track on concentration. All right, so I've written down this question again. So see, now we are going to keep a track on the concentration. And again, since we know that pure water is being added, we'll keep a track on the concentration of milk. So the concentration of milk is 7 by 12. And again, the total volume is 125. We know this. This is the total volume after all the six events take place, because we have earlier solved it using by keeping a track on quantity. So let's start. And okay, even before just writing all of it down, just remember that when x% withdrawal happened, there was no change in the concentration. So when when you're saying that 10 liters is removed, there will be no change in the concentration. The only change will be if you add quantity A, the concentration of quantity B will decrease. So in this situation, when you have removed 10 liters, the volume now is 90. The volume now is 90. From 100, now it's 90. And when you add 30 liters of water, the volume now is 120. And because of that formula, that now the concentration of milk, here we are writing the concentration of milk, this concentration would decrease. And the formula was that the initial concentration multiplied by the initial volume divided by the final volume. Initial volume, final volume. And again, you should know that there are just two numbers, 90 and 120. And we know that the concentration is going to decrease. So you would just have two options, 90 by 120 or 120 by 90. You know that it's going to be less than 1, so it will be 90 by 120. This is even if you don't click, it doesn't click, the formula doesn't click, you just use this logic with you. Okay, so after that you're again removing something, and when you remove something, the concentration will not change. So now you just have to note down what the volume would be. So the volume from would now decrease from 120 to 100. After that, you're adding 50 more liters. So the volume now is 150. And again, you can, think of it by, recollecting the formula, or just, see these two values, 100 and 150. The multiplier would be less than 1, so it will be 100 divided by 150. And after that, again, you're, withdrawing something, you'll be having 120 liters as the total volume, and your concentration, it will remain the same. And after that, now you're increasing, you're adding 5 more liters, so your volume would be 125 liters. Again, you have two values, 120 and 125. It will be 120 divided by 125, and this is the concentration of milk, and this is the final amount. See, because of this, as I, stated earlier, that I like the, by, tracking the concentration method more than the quantity method. And here's why: because I feel that it's much neat, and it's more, quicker according to me. But that's a personal choice again. So now again, let's, calculate all of the, all the concentrations and all the quantities. Okay, so if we, just find out these values. So this will be a 4, this will be a 5, these two will get cancelled out. 3 3s are 9, 3 5s are 15, and we can have a 3 here, and these two get cancelled out. So the final concentration of milk, it becomes 7 by 25, and the concentration of water becomes 18 by 25. And these were the exact results, that we got when we did it by the quantity method, of course. So, and again, we also know that the final, this final volume would be 125. So from the final volume and the concentration, we can have the quantities. So the quantity of milk would be 7 by 25 into 125. So that's 35 liters. And then the quantity of water would be 18 by 25 into 125, and that's 90 liters. So this is how, you find everything, you analyze the situation after all the events using the concentration method. Okay, so we have this special kind of questions where it will be written that, X% of the solution is, removed, and then that amount is, replaced by some pure quantity. So if we take the example of milk and water, so maybe, 10% of, let's say, the total solution was removed, and then that will be, if we take in as 100 liters as the total initial volume, so we are now left with 90 liters, and then we add, 10 more liters of water to it. So in these, in such kind of a question, it could be like, the question could be that such a thing is repeated 5 times, 10 times. So just let's just talk about when it happens only one time. Okay. So in that case, after these events happen, after, X person is withdrawn and then, replaced by water, the quantity of milk would be the initial quantity, multiplied by that multiplier. In this case of minus 10%, it will be 9 by 10. And same would be the case for, the concentration. And we can actually, analyze this, how this is correct. So initially we have 100 liters, and we are saying the ratio as 4 is to 2 is to 3, 40 liters of milk and 60 liter of water. And then 10% is removed. So, we are left now with 90 liters. And then 10 liters of water is added, and now we have 100 liters, right? So, in this 90 liters, as we have, already seen, we will have 36 liters of milk and 54 liters of water. And now in this, we are adding 10 liters of water. So, we have 36 liters of milk and 64 liters of water. So now if we have to check this relation, validate it. So let's talk about the quantity. So the final quantity is 36. We are talking about milk, right? So the final quantity is 36. Quantity m dash is 36, and the initial quantity was 40, and we had minus 10. So this x, this x percent, it was 10%. So we had the multiplier as 1 plus minus 10 upon 100, that is 90 by 100, or 9 by 10. So we can see that 36 is equal to 40 multiplied by 9 by 10. And you can see that how, because in these two events, so initially x% was withdrawn and then replaced with same amount of water. So for quantity, this second event didn't matter, and this x% withdrawn, this formula is for this particular event only. And the interesting fact to notice here is that this initial volume and this final volume, these values are the same. And because of this very reason only, we have this second equation, that the concentration has a similar type of an equation. So we can check this as well. So the initial concentration was, the Cm was for milk 60, I'm sorry, 40 by 100, and the final concentration is 36 divided by 100. So you can see here, this denominator remains the same. So obviously Cm is equal to 40 by 6 by 100, which is equal to one sec. So this will be multiplied by 1 minus x by 100, right? And this x, we have given it as 10. So we have Cm dash, which is equal to 36 by 100, that's 40 by 100 multiplied by 9 by 10. So we have Cm dash equal to Cm multiplied by 1 minus x by 100, and we have proven that why the statement is correct. And let me give you one final mathematical relation for this. See, we had understood, because that addition of x% again of pure water didn't actually matter for the quantity. So qm dash was equal to qm multiplied by 1 minus x by 100, and that is our multiplying factor. And for concentration also, we prove that that relation holds true. But why does that happen? That's because the final volume and the initial volume, they are the same value. In that example it was 100, and also this was again 100. So because of this reason, you can see that whatever relation cm dash and whatever relation qm dash and qm holds, that will be true for cm dash and cm, because this will get cancelled out for both of these. So if you have qm dash equal to qm multiplied by 1 minus x upon 100, if you just simply divide by v, if you just divide both sides with v, you will get this as cm dash and this by cm. So because of the reason that the initial volume, the initial total volume is equal to the final total volume, because of that the same relation holds true for concentration. And this is the special kind of question wherein you can just, if you just see that you can do it for concentration or do it for quantity, you just have to multiply it this by multiply the initial quantity or the initial concentration by this factor. And if it's written that such a process happened for, let's say, n times, 2 times, 3 times, 5 times, n times, so your final relations would be that qm dash is equal to qm multiplied by 1 minus x upon 100 to the power n. And you can see that because after, like, let's take the example of that this, this set of events happen twice. So when, it'll happen for the first time, you will have qm dash as, let's say, qm dash dash. This is, after the first event happens, that will be qm into 1 minus x upon 100, right? And now this is your quantity, and again those two, events are happening. So qm dash would be equal to qm double dash 1 minus x by 100, and again this is nothing but qm multiplied by 1 minus x by 100 to the power 2. And this 2 was the number of sets of those two, events that x person withdrawn, and then the same amount is added, the opposite quantity, the other quantity. Water was added and we are talking about milk here. So that happened twice, and if that happens n times, so you have your formula right here. So I hope this was helpful.